welcome to Science Aura. I'm Dr. Sachi Vale. Tonight, we journey to our cosmic neighbor, the majestic Andromeda galaxy, a breathtaking spiral of billions of stars. It hangs in the cosmic void, a beacon inviting humanity to ponder the impossible journey across its immense expanse. For millennia, humanity has gazed at the stars, driven by an insatiable curiosity to explore beyond our terrestrial home. This innate drive fuels our dreams of interstellar travel, pushing the boundaries of what we believe is possible. The dream isn't just to visit other planets, but to traverse galaxies, to touch the distant shores of Andromeda itself. It's a quest that challenges our very understanding of time, distance, and technological limits. Andromeda, our closest galactic neighbor, is a spiral of immense beauty and mystery. It beckons, a cosmic siren call, promising new worlds and untold discoveries, if only we could reach it. But this interstellar quest is fraught with unimaginable challenges. The vastness of space, the tyranny of distance, and the limitations of our current technology make Andromeda seem an impossible dream. To truly grasp the scale of this journey, we must first understand the distances involved. Andromeda lies approximately 2.5 million light years away. But what exactly does a light year mean? A light year is the distance light travels in one Earth year, an astonishing 9.46 trillion kilometers. It's the ultimate cosmic yardstick, yet even with it, the numbers become mind-boggling. Our fastest current spacecraft, Voyager 1, serves as a stark reminder of our limitations. It's a tiny, solitary explorer, crawling through the void at a speed that is, by cosmic standards, incredibly slow. Voyager 1 travels at approximately 17 kilometers per second, or over 60,000 kilometers per hour. For human engineering, this is a phenomenal feat, a testament to our ingenuity. Yet, on an interstellar scale, this speed is negligible. To truly appreciate this, imagine the vast emptiness between stars, the unimaginable gulfs separating galaxies. If we were to attempt the journey to Andromeda using Voyager 1's current speed, the numbers become truly staggering, defying all human intuition and experience. This cosmic odyssey would take billions of years, a time frame so vast it renders the concept meaningless in human terms. Our sun, our very solar system, would have long ceased to exist. Such a journey transcends individual lives, entire civilizations, even geological epochs. It's a timescale that truly belongs to the universe itself, not to our fleeting human existence. Our current technology, impressive as it is for exploring our own solar system, simply isn't designed for such unfathomable distances and durations. A new approach is desperately needed. We need to rethink propulsion, energy, and even the very concept of a journey itself. The challenge of Andromeda forces us to innovate, to dream bigger, and to look beyond the immediate. Current propulsion systems, primarily chemical rockets, are marvels of engineering for escaping Earth's gravity and navigating our solar system. They are powerful, but incredibly inefficient for interstellar travel. Chemical rockets rely on expelling mass at high velocity to generate thrust. They carry all their fuel with them, making them heavy and limiting their sustained acceleration and range. Once that fuel is expended, they become coasting objects, slaves to inertia. For interstellar distances, we need continuous, powerful acceleration over incredibly long periods. Even more advanced systems, like ion thrusters, while incredibly fuel efficient, offer accelerations too minuscule for galactic travel. They're excellent for fine-tuning orbits, not crossing light years. To reach Andromeda, we need a paradigm shift in propulsion. We require systems that can generate enormous, sustained thrust, pushing a spacecraft to a significant fraction of the speed of light. This means moving beyond chemical reactions and even basic electrical propulsion towards harnessing more fundamental forces of the universe. It's a leap into theoretical physics and engineering. We need to approach relativistic speeds, where the laws of physics begin to bend, and familiar concepts, like time and mass, behave in unexpected ways. This is where the true engineering challenge begins. The sheer scale of such a project, the resources required, and the technological leaps needed are staggering. It demands a global, multi-generational commitment, unprecedented in human history. Yet, the dream persists. The allure of Andromeda, the potential for discovery, and the profound implications for humanity's future continue to inspire scientists and engineers worldwide. It's a testament to our enduring spirit of exploration, a silent promise whispered across the light years. We will find a way to reach you. One of the earliest and most powerful theoretical solutions is nuclear pulse propulsion. Imagine a massive interstellar vessel propelled by a series of controlled nuclear detonations. The concept is simple, yet audacious. Small nuclear bombs are detonated behind a pusher plate at the rear of the ship. Each explosion imparts a powerful impulse, propelling the vessel forward. This method could theoretically accelerate a spacecraft to a significant fraction of light speed, far beyond anything achievable with chemical rockets. It's a brute force approach to interstellar travel. Project Orion, a real-world concept from the 1950s and 60s, explored this very idea. It proposed journeys to Mars in weeks, and even to Alpha Centauri in decades, not millennia. However, even with nuclear pulse propulsion, the journey to Andromeda would still take millions of years. The sheer scale of the distance overwhelms even this immense power. The number of nuclear bombs required for such an epic voyage would be astronomical, raising significant logistical and ethical concerns. Where would we store them all? Furthermore, the environmental implications of detonating thousands of nuclear devices in space, even in the vacuum, are daunting. The potential for radiation and debris is immense. While nuclear pulse propulsion offers a powerful theoretical pathway, its practical implementation faces colossal hurdles, both technological and ethical. It remains a concept on the drawing board. It is a testament to the raw power we can conceive, but also a stark reminder of the responsibilities that come with such capabilities. The cosmos demands a cleaner solution. So, we continue our search for propulsion methods that are not only powerful, but also sustainable and safe for a journey of unimaginable duration and scale. Antimatter propulsion offers an even greater theoretical promise, representing the pinnacle of energy conversion. It's the most efficient energy source known to physics. When matter and antimatter collide, they annihilate each other, converting 100% of their mass into pure energy. This is far more efficient than nuclear fission or fusion. This incredible energy yield means an antimatter-powered vessel could potentially reach a significant fraction of light speed, perhaps up to 90% or more, making interstellar journeys far more feasible. Imagine a vibrant, focused beam of light emanating from the ship's engine, pushing it ever faster through the cosmic void. The stars outside would begin to streak dramatically. However, creating and storing antimatter is currently one of humanity's greatest technological hurdles. It requires immense energy and incredibly sophisticated containment fields. Antimatter is produced in minuscule quantities in particle accelerators, far less than what would be needed to even power a small probe, let alone a massive interstellar vessel. Even if we overcame these challenges, the journey to Andromeda would still take hundreds of thousands of years. A monumental reduction, but still far beyond a single human lifetime. This means that even with antimatter, the crew who set out would not be the same as those who arrive. It's a journey across generations, a profound testament to enduring human ambition. Antimatter propulsion represents the ultimate challenge in harnessing pure energy, pushing the boundaries of what we can control and contain. A true frontier of physics and engineering. The scientific hurdles are immense, but the potential rewards, a faster path to the stars, are equally compelling. It's a technology that could redefine our place in the cosmos. What about time dilation? A mind-bending phenomenon predicted by Einstein's theory of relativity. Could it be our secret weapon against the vast distances of space? Time dilation states that as an object approaches the speed of light, time slows down for that object relative to a stationary observer. A journey of centuries for Earth might be mere years for the traveler. This sounds like a perfect solution, allowing a crew to reach Andromeda within a single human lifetime, experiencing only a few years while millennia pass on Earth. The ultimate shortcut. However, the speeds required to achieve meaningful time dilation over such vast distances are almost unattainable. We're talking about incredibly close to the speed of light, 99.999% or more. To accelerate a massive interstellar vessel to such extreme velocities would demand catastrophic amounts of energy, far beyond anything we can currently conceive or generate. The energy required increases exponentially as you approach light speed. Every additional fraction of a percent demands an impossible amount of power, turning the ship into a pure energy projector. And then there's the equally challenging problem of deceleration. Stopping a ship traveling at near light speed upon arrival at Andromeda would require an equally immense amount of energy and precision. Any tiny error in trajectory or braking could lead to catastrophic consequences, as the ship would possess unimaginable kinetic energy capable of destroying anything in its path. So, while time dilation is a fascinating aspect of relativistic travel, it's not a silver bullet for reaching Andromeda within a single human lifetime. The energy barriers are simply too formidable. It pushes us to consider alternative strategies, ones that embrace the long timescales of cosmic journeys rather than fighting against them. A different kind of solution is needed. Given the immense distances and the limitations of even advanced propulsion, the most feasible answer for reaching Andromeda lies in generation ships. These aren't merely vessels. They are self-sustaining worlds. Colossal arks designed to carry tens of thousands of lives across the vastness of interstellar space for millennia. A generation ship is a cosmic ark, a mobile ecosystem complete with its own atmosphere, water cycle, and intricate food production systems. It's a closed loop designed for ultimate self-sufficiency. The journey would span countless human lifetimes, with generations born, living, and dying aboard the vessel. Their mission, passed down through oral tradition and recorded history, is to reach Andromeda. In Vietnamese, such a vessel might be called a viễn, phương, chu, a distant voyage ark, a poetic and fitting description for these monumental endeavors. These vast ships would house complex ecosystems, from forests and rivers to vast agricultural zones, all meticulously managed to provide for the inhabitants for thousands of years. Their primary mission, to preserve humanity's knowledge, culture, and genetic legacy. To be a living time capsule, carrying the essence of Earth across the cosmic ocean. Even at advanced sublight speeds, the journey would still demand hundreds of thousands of years. The generation ship is a commitment to a future none of its initial crew will ever witness. It's a monumental undertaking, pushing the very limits of engineering, biology, and sociology. A project that demands foresight beyond anything we've attempted before. The generation ship is a testament to humanity's enduring spirit, our capacity for long-term vision, and our collective will to ensure our survival beyond our home world. But generation ships, despite their promise, present unique and profound challenges that extend far beyond engineering. The human element becomes the most critical and perhaps the most fragile component. Maintaining social cohesion and a shared sense of purpose across hundreds of generations is an unprecedented sociological experiment. How do you prevent cultural drift or loss of mission? The psychological toll of living in a confined artificial environment for an entire lifetime, let alone multiple generations, is immense. How do you maintain mental well-being and inspiration? Ensuring genetic diversity and avoiding inbreeding over such long periods is a complex biological problem. Careful genetic management would be paramount to a healthy, sustainable population. The technology itself must be incredibly robust, self-repairing, and capable of being maintained by successive generations who may not fully understand its original design or purpose. Imagine a miniature civilization, adrift in the cosmic ocean, entirely reliant on its internal systems, and the wisdom passed down through time. A solitary beacon in the vast darkness. Every system, every tradition, every aspect of life within the generation ship must be meticulously planned and rigorously adhered to ensure the success of the multi-generational journey. It is an act of profound faith in humanity's future, a commitment made by those who will never see the destination for the benefit of those who will, thousands of years later. The journey to Andromeda, therefore, is not just about overcoming technical hurdles. It's about overcoming our own human limitations, our short lifespans, and our inherent need for immediate gratification. It's a testament to our capacity for collective ambition and sacrifice, for a legacy that transcends individual existence, the true meaning of a cosmic odyssey. Ultimately, the journey to Andromeda isn't solely about achieving incredible speeds or building colossal ships. It's a profound test of humanity's endurance, ingenuity, and collective will. It challenges us to think on timescales far beyond our own lives, to plan for futures we will never see, and to sacrifice for generations yet unborn. It's the ultimate long game. This cosmic quest forces us to confront fundamental questions about our survival and evolution. Can we adapt to a life among the stars? Can we maintain our humanity across vast cosmic distances? The journey to Andromeda is more than just a trip. It's a transformation. It's the ultimate step in becoming a truly interstellar species, ensuring our future among the stars. Will humanity eventually reach the distant shores of Andromeda? Only time and our unwavering resolve will tell. But the dream, the quest, will forever burn brightly in our collective imagination.